Let f be a function, then the following statements are equivalent. The inverse of f is a function, f is 1 to 1, and the graph of f passes the horizontal line test. That means that all of these things are true, because they're all the same thing. So if I say that the inverse of f is a function, then you know f has to be 1 to 1 and it passes the horizontal line test. If I just told you f passes the horizontal line test, you would know that f is 1 to 1 and the inverse of f is a function. Just that easy. The inverse function, if it exists, is written as f to the negative first power, where if y equals f of x, then x equals f inverse of y. All that's saying is we just do the opposite of what we just do what we did yesterday as far as flipping your x and y and then solving. Restricting the domain. For a function that is not 1 to 1, it's possible to produce an inverse function by considering only one part of the function that is 1 to 1. This is called restricting the domain. Find an interval on the function f of x equals x squared. Find an interval on which the function f of x equals x squared is 1 to 1, and find the f inverse, or the inverse function, on that interval. So I'll have you write this down, and then we'll do it together and see what it's talking about. Now, if we look at y equals x squared, or f of x equals x squared, then what I have is a parabola. And as a matter of fact, I might copy a piece of Desmos so we can see this clearly. Okay, so I drew this parabola. I wrote all the numbers in perfectly. I did it all by myself. Okay, so basically, if I run this by the horizontal line test, I'll find that the inverse function is not 1 to 1, or is it? It is not 1 to 1 because the horizontal line touches 2 points anywhere I put it. And all it has to have is have that happen one time, and it's not 1 to 1. So what we can actually do to this is we can restrict the domain of the original function to make it so that it would be 1 to 1. What does that mean? Well, I'm going to tell you what that means. That means that there's something that I can do and put some kind of restrictions on my x's to make it so that it would be 1 to 1. In other words, what if I did that? Does that graph look 1 to 1 now? If I take my horizontal line and I run it through there, it's not going to hit 2 spots at once. See, now if I draw a horizontal line through there, it doesn't hit it 2 spots at once. It only goes through 1 spot each time. It only goes through there. There's nothing over here. So that's essentially what we're doing. We're creating this white block and we are blocking out half of the graph. So I can restrict my domain starting at x equals 0 and say the domain would be from 0 to infinity. Then it's always going to be 1 to 1 if I cut the left side of the graph off. If I stop it at 0, then I'm restricting my domain so I can't go back to the left any further, and it makes it so that the right side will always work. So now we've created a function that is 1 to 1. Could I have reversed this? Of course I could. I could move my white block over here. And when I do that, you'll see that my domain is from 0 to negative infinity. That's another option. Getting rid of the entire right side of the graph. Makes it so that I can come up to 0 and stop, and none of my points will ever repeat. Okay, composition of a function and its inverse. The inverse of a function f is designed to send each output of f back to the input that it came from. So f of a equals b exactly when the inverse of b equals a. So then if I have the f inverse, or the inverse function, of the function f of a, that would be equal to the inverse of b, which is equal to a. All right, so that's all we have to talk about, and let's have a good day. I'm kidding. That looks more difficult than it actually is. It's saying if I take the inverse of the original function, then that's equal to the inverse of our output, which equals what we put in when we started. A one-to-one function and its inverse function, f to the negative first, have these properties. If I take the inverse of the original function of x, it's equal to x for every domain x in the function of f. And it works in the exact opposite way. If I take f inverse and view the composition of that with f of x, for every x in the domain of f inverse, that gives us just x. Don't worry, don't cry. On Monday we'll do some examples and you'll understand this entire slide. Okay, have a great weekend. Bye.